Okay, Dave, so this is going to be just kind of an overview of what you missed over distance and midpoint formulas. It's pretty basic. You've probably seen them before. So the first thing that we're going to do is we are going to plot my 1, 2. So I go over 1, up 2. Normally with Euclidean geometry, we can label that point A. And then we're going to plot our over 7, up 6. Over 7, up 6, we plot it with a capital letter B. Okay, so what you're going to do is you are going to connect your dot. Again, this is a line segment, not a line. Okay, yes, it is a line, but we are going to call it a line segment so that we can find the distance for it. Right? The next question on here says, what is the slope of our line? There's a couple ways that you can find slope. Okay, you have your slope formula, your y2 minus y1 over x2 minus x1. Okay, this is known as the change in y over the change in x. Okay, but essentially we're trying to figure out our rise over our run. So we go up 1, 2, 3, 4, and we run 1, 2, 3, 4, 5, 6. So the distance from here to here is 4, and the distance from here to here is 6. So our slope is our rise over our run, which you then can simplify your ratio to 2/3. Okay. Now again, the purpose of this lesson is to kind of show you how we derive the distance formula. And so we're going to use our Pythagorean theorem because what we've created is a right triangle. Okay, we have our A and we have our B. Now we're looking for our C. So I'm going to go ahead and show you guys that right here. We have our A squared, so 4 squared, plus our B squared, 6 squared, equals our C squared. Okay, you can use your calculator for this. If you know it in your head, that's fine. So we have our 16 plus our 36 equals C squared. We add those two together, we end up with 52 equals C squared. Now we're not finished because we want just C. So to undo a squared term, we must take the square root of both sides. Okay. So when we do that, we get C is the square root of 52. Now this may not be something that we go into a whole lot of detail on now, but we eventually will be simplifying our square roots. So you have to think about your perfect squares. But if you were to just type this into your calculator, it would also give you that answer and give you an approximation. Okay, so I'm going to go ahead and let you do that. Okay. Now, with our distance formula, we have D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the formula. It's going to be something that I will have on the board for you. You don't necessarily have to memorize it, but I want you to see the connection between the two. Again, we're trying to find AB, so I'm going to relist those points. So my A, I have 1, 2. My B, I have 7, 6. Okay, with ordered pairs, we always list our X first, then our Y. We're going to do the same thing for both of them. Okay. Now, if you notice, I have X1 and x2. Okay, this is our first point, so we're going to go ahead and just label it x1, y1. This is our second point, so we'll label it this. Okay, so then we have our D equals the square root of our x2, so our 7, minus our x1, which is 1, squared, plus our y2 minus our y1 squared. Now, some of you might be asking, okay, well, do I have to choose that point first? Do I have to choose B as the second and then A? And honestly, it really doesn't matter because of this squared term here. Okay, so we go ahead and fill this out. 7 minus 1 is 6 squared, plus 6 minus 2 is 4 squared. Now, if you flip it over to the back page, again, we've already looked at how the Pythagorean theorem relates to the distance formula. And what you're going to see is it asks you to plot the following points on the triangle. So 1, 2, 1, 4, and 4, 4. So I'll do that for you over here with a different marker. So here are these, and I will shade it in. Now what you're going to notice is that this triangle has a slope of 2 over 3, which is similar to what we saw down here for the original slope. What that means is that these two triangles are proportional. Okay, they're not congruent because the sides are not the same, but they are proportional. And this point right here, okay, this is called our midpoint. It is the same distance from here to here as it is from here to here. Okay, so when we find our midpoint, we are finding a triangle that is just proportional to the larger triangle. Now there's a formula for it. Okay, and I'll go ahead and write that here. So we have the midpoint is our x2 plus our x1 divided by 2, and our y2 plus our y1 divided by 2. Okay, so we're just adding those two together, and we're dividing by 2 for each one, just depending on your point. Okay. Now, with this, there's a couple questions at the 1 through 5 that are on the bottom, so I'm going to work those problems out using another sheet of paper so that you can see how I work them out. And that way, if you have any questions, you can look back at this recording and look at it. Okay. So we have our point C is at -3, 4, and our D is at 0, -1. If we're finding the distance, okay, again, we can go ahead and label our points X and Y. And then let's say this is our first point, so we put a 1. And then here's our second point, we put our 2. So we take our x2 minus our x1, that all has to be squared, plus our y2 minus our y1 squared. Now most of you would say, okay, looking at this, I know that those two are going to be a positive, but you also need to make sure you know why. There's a number right in front of my parentheses. It's a 1. Okay? So what we're essentially doing is we're taking our -1 and we're multiplying it by our -3. Well, you guys know that two negatives are always going to make a positive. So then we can say that those become plus. So 0 plus 3, okay, is going to still be 3. Excuse me. So we have our square root of 3 squared. Then we have a -1 minus 4, so we're going to be becoming more negative. So I'm going to keep this in parentheses, my -5 squared, and then we have to keep our operation here. Okay, so then we have 3 squared, which is 9. Okay, make sure you keep your square root with it, 9. And then the square root, -5 squared is going to be 25. So we get the square root of 34. As our answer. And you'll be able to put this into your calculator. I'm not going to make those calculations for you. Okay. Now if we're trying to find the midpoint, it's a little bit different formula, but it's essentially the same. We're just going to be plugging in numbers. So we have our midpoint. I'm not going to use M because we already have a formula with M in it. So my x2, 0, plus my x1, so I'm going to put that in parentheses just so I don't forget. And then I have my y2, -1, plus my y1 divided by 2. Okay. So we have 0 plus -3 gives me -3 over 2. And then we have -1 plus 4 gives me 3 over 2. And there is your midpoint. Okay. So all you're doing is plugging in the information into the formulas, and you're putting it out on your paper. Okay. So this is going to be a distance. This is going to be a coordinate. Okay. Now, if you look at problem number 3, it's a little bit different. Okay, it says to find the endpoint of C if M is the midpoint of segment CD, where M is 2, 4 and D is 5, 7. Okay, so if you think about that graphically, it's a little bit easier to understand because you're able to graph it. But I also want you to be able to do it by hand in case you don't have a graph piece of paper to use. Okay? So let's go ahead and find that other midpoint. I'm going to draw a sketch of it over here just so that you guys can see. So we have over approximately 2 up 4. We'll call that our point M. And then over D is 5 up 7. So we're about right here. Again, this is just a sketch. It's not true to scale. So what you can see, though, is if this is the middle and this is the end, then we're going to have to go in this direction to give us our C. Right? So you can either count slope up to that point and then count this way, and then go the other way with it and count that way. But you're not always going to have a piece of graph paper. So with that said, I wanted to go ahead and show you how to do this without using your graph paper. Okay. Now we said our midpoint formula is our x2 plus our x1 divided by 2. And then we have our y2 plus our y1 divided by 2. Now we already know what the midpoint is. 2, 4. So what we're going to do is we're going to use one of the points that was given to us, which was our D as 5, 7. And we're going to plug this into our formula. Okay. So we can just leave our x2. We'll say that this is our x1, y1. So I'm going to plug that in, plug my 5 in over 2. So this right here is going to give me my x coordinate. But look what it tells us our x coordinate for our midpoint is. It's 2, so I'm going to plug that in. This is my y coordinate, which we already know what it is, so we're going to plug our information into that. So I have y2 plus 4 divided by 2 equals 4. Excuse me, I'm going to change that. Sorry, that's my fault. That becomes a 7. I'm sorry. We're going to take our y1 and plug it in. Our 4 goes on the end. Now, just like back in algebra, okay, we're going to be trying to solve for our x2. So I'm going to have to multiply both sides by 2 because 2 over 2 is 1. It doesn't just cancel out, it becomes 1. And what I do to one side, I must do to the other. So I have x2 plus 5. 2 times 2 is 4. And then we have to solve. So I'm going to subtract 5 from this side because that becomes 0. And then I must subtract 5 over here. So my x2 coordinate is 4 minus 5, which is negative 1. We're going to do the same thing to the other side, or to the other coordinate. We're going to multiply both sides by 2.
If you're in the building, please come to the front office. Via Trevino to the front office.
So we have 2 over 2. Two over 2, which is 1. So we'll have our y2 plus 7 equals 4 times 2. So y2 plus 7 equals 8. I then have to subtract my 7 from both sides, and I'm left with y2 equals, that becomes 0, 1. So the other coordinate that you have is your x and then your y. Okay, so the other thing that we're going to look at is finding it on a graph. So I'm going to be looking at question number 4. Again, it says that your point A is over 1 up 2. That's your point A. And then your point M, your midpoint, is over 6 down 2. Okay. Now, again, this is a really easy method. Okay, I'm going to go ahead and connect those two. If this is my first point and here's my midpoint, the only other option I have is to put my other point down here. So this is the counting method. I think it's a really easy way. We're going to be looking at our rise and our run. So if I rise 1, 2, 3, 4, I'm going to have to go the opposite way in this direction. 1, 2, 3, 4. If I run 1, 2, 3, 4, 5, I'm going to have to run 5. 1, 2, 3, 4. I know it's not on their graph, but it's going to be right here. So here is your other endpoint. Okay? So again, 2 different ways to show you. This one is if you have a graph. The other one is if you do not have a graph.